Hello everyone, welcome to my channel. In this video, I'm going to talk about indexing in SQL Server. To be more specific, I'll share what is index and why we need them with specific examples. Afterwards, I will talk about index types in SQL Server, including clustered and non-clustered index. Finally, I will end this video by talking about covering and include indexes. If you find this video useful, please do not forget to subscribe to follow my future series. Let's get started. First of all, what is index? An index is a feature that improves the performance of searches, and in this way, the performance of the queries in SQL Server. That's it. Okay? We can say this is similar to the index of a book, where page numbers are mapped to the keywords. A book index helps you to quickly go to the page containing the word you are searching for, right? If there is no index, you may have to rely on your memory, intuition, or you may have to search the word by going through each page in the book. This is very time consuming, right? So we need book index for this. The same applies to the tables and indexing in SQL Server. Indexes allow SQL Server to quickly search for data in a table. Without indexes, SQL Server has to search through all the data, which can be very time consuming in the case where you have a huge data. Let's see how it happens by looking at the internal behavior of SQL Server when there is no index. So basically, data is saved in the order of the insert in tables without indexes. But data change and delete operation change the order of saved data, right? Consider the following employees table as an example where there is no index. Let's run select query to find an employee with first name, James. SQL Server does not know where this data is located. Therefore, SQL Server has to search for the data by going through each row in the table. For example, let's illustrate this process. SQL Server searches the data with first name until row 25, found one value, right, matching the query. Then the search will continue until row 42, then again with the same process until the end of the table. This process happens with every table without any index, and it is very time consuming. Let's see what happens if we do have an index. If we have an index for the first column, SQL Server does not need to search for the whole table, but directly finds the records. This is very efficient, right? Let's see this in SSMS. I have restored AdventureWorks 2019 in SQL Server 2019. As you can see, there are many tables, and I'm going to use person table in this demo. This is already ready table with several indexes. So therefore, I cannot use this to test the indexing, okay, in our demo. So what I'm going to do is just to create a copy of this table. By running this command, first I'm going to create the table with the same columns, okay? So if we check the inside of it, we don't have any column. So if we refresh here, we can see that person copy, okay, it's here, and the columns are the same, okay, but there are no indexes. I'm going to insert the data to the table. Okay, we just run this command, and if we check it, now we can see that there is a data inside this. Next thing we are going to do is just to query this table. We will try to find a record with the first name James. Okay, we just run this. As you can see, we got the results, all of the James, and we can see that message 97 rows has been extracted. Okay, now we can see also execution plan. By the way, you can enable execution plan by just going to query, okay, and then include actual execution plan. So execution plan is showing that SQL Server used table scan. In other words, SQL Server scanned all of the table, okay? And this way of getting the result is called table scan, okay? If we look at this table scan, we can see that number of rows read, okay? So this shows that SQL Server has read all of the rows in the table, right? And the actual number of rows for all executions, and it shows that how many rows has been extracted, okay? By reading all of the rows, SQL Server is returning 97 records, okay? So we can see that table scan is very much inefficient way of getting the data because we are checking all of the rows, okay? Now we want to check with clustered index. We just create index based on the column called first name. Why first name? Because we are searching the record based on this column. Okay, we just run this, execute, and now try to run this, execute. As we can see the execution plan. Okay, now as you can see that the way of extracting has been changed from table scan to clustered index seek. Okay, no worries about what is table scan, what is clustered index, what is non-clustered, what is seek, scan. I will explain it later. Now just pay attention how the data is being extracted with the help of index, right? So now you can see that number of rows read is only 97. In other words, SQL Server is not reading all of the rows, right? It's reading only 97 rows, only the necessary rows, and returning 97 records. This is very efficient, right? Now we have very low data, very much small data, but in the case of terabyte and petabytes of data, this becomes very, very efficient, and your query becomes very fast. So I just showed how the indexing works in SQL Server and why we need index. Okay, we understood the importance of indexing in SQL Server queries. Now, let's deep dive and understand how indexes are built by looking at internal structures of an index. But beforehand, to understand indexing, it is important to understand the internal structure of the database. Therefore, let's start by understanding the internal structure of the database in SQL Server before moving to indexes. Each database in SQL Server contains at least one data file and transaction log file. Each data file contains 8 kilobyte size data pages. SQL Server extracts data from disk at page level. From disk to memory, to buffer pool, right? Each page contains the actual data, and the group of pages are located in a heap. In other words, heap is a group of unclustered pages. I want to also mention that a collection of 8 pages is called an extent. When data is added, one extent is allocated, and subsequently added data is stored on 8 consecutive pages. This ensures that the data for the same objects is stored on 8 consecutive pages. Storing data of the same object helps to improve reading and searching performance. Now we understand the structure of the database. Let's switch to the structure of indexes. There are 2 types of indexes in SQL Server, clustered and non-clustered index. I will start with non-clustered index. First, index structure is architecture which is based on the tree structure. Okay, it is based on tree structure. First level is called root node and contains one root page. After root node, here comes middle nodes. Middle node may consist of several levels based on the data. In our case, it consists of only one level since we have very small data. After middle level node, lastly comes leaf node where index architecture ends. As you can see, in each level, data is stored based on the first column, which is first name, right? The next is lower page IDs in root node and middle nodes only. In the leaf node, however, it becomes row ID, which is called RID. RID, it is like first number is file ID, second one is heap page ID, and third one is row number in page. Let's see how the flow of query in this architecture works. We run this query, okay? First, the flow starts with root page, and SQL Server defines Jack and Murphy rows there. SQL Server understands that James is between these rows, based on the alphabet, right? Therefore, it selects page number 33, then it goes to page number 33 at lower level. There, SQL Server finds a Jack and learn, and understands that James should be in 169 since next row is already starting with letter L. Okay. As a result, page number 169 is selected and James row is found there. Here we find that James is located in file numbered 1, page number 402, and is the first row of heap or heap table, we can say. Then the result is returned. If we have several records of James, we would have many records in leaf node here. I just want to mention. Okay, all the operations we just saw is called non-clustered index seek with row ID lookup, RID lookup. Okay, in SQL Server. Please do not forget this. Let's see this process in SSMS. As previous demonstration, first of all, I will create a table called person copy. Then I'll just insert data inside this table. Okay. So if we select, we can see that now we have data, right? So before doing anything, I will just check whether there is any index in this table. We will just can have a look right here. There is no index. Now, to improve our operation, I will just create non-clustered index called ix person. Okay, we will just create a non-clustered index by using this kind of query. And when we just create by running this query. Then we will just check how it performs. Okay, we will just go to execution plan. Here you can see that index seek non-clustered on person copy table by using ix person non-clustered index, okay, and by using row ID lookup, okay, on heap table, as you can see. So this is all we talked about until now, okay. So after creating a non-clustered index, you may want to see how many pages in each level, right? So in order to do this, we can just use a simple query. First of all, we will find out index ID of our created index, okay, by using this kind of query. Here, I'm selecting name and index ID, and our object ID is person copy, okay, our table ID. So we just get index ID. Here we can see that our index ID is 2, right? Then we will just run this query. Okay, db index physical stats. So this gives this output. Here we can see that index level 0 and 1. It shows that we have only two level, leaf and root, okay. This shows that we might not have sometimes middle level page, okay. Our index may consist of only leaf level and root level, and in each level, we can see that in root level, for example, only one page, and in the leaf level, we have 75 pages. Okay, this is just one example. Sometimes, even if you create non-clustered index, you might notice that this index is not being used. Instead, table scan is being used. When you face this issue, firstly, when indexed column is not used in queries where close. You should always use indexed column in where close if you want SQL Server to implement indexes in the query. Secondly, when SQL Server finds that table scan or non-clustered index scan is faster than non-clustered index seek. Okay, we already know what is a table scan, right? Table scan is searching for the record by going through all the records in the table, while non-clustered index scan, which is also logically equal to table scan, is scanning the whole leaf node. Indexes are most effective when retrieving 1 to a few hundred data items from a large amount of data. If there's a large amount of relevant data while you are querying, the RID lookup might be costly, right? I mean, going through from the leaf node until the going through from the root node until the leaf node might be very costly, right? If you have many items, and it might be less efficient than table scan. SQL Server just instead of going through all of the steps in the node, like index nodes, table scan SQL Server can easily scan all of the data in the table and just can give you as a result. It might be less efficient. Let's see this in SSMS by running the query. As you might remember, we created non-clustered index by using first name column in our previous example, right? So after that, we have successfully implemented this non-clustered index to get the all records with James, right? I'm sorry, I think it was James before. Let's say James, yeah. And if we implement this, we can see that we are successfully implementing our non-clustered index. But instead of first name, if we try to implement middle name, right? Non-clustered index in this case is not used. Instead, table scan is being used. Why? Because first name, we have created unclustered index based on the first name, right? But we are using middle name in our where clause. So therefore, table non-clustered index is not being used, although it is much efficient. Furthermore, if we do not use any column in where clause, okay, if we try this, we can see that anyway table scan is being used. In short, to summarize, as we talked before, we should use non-clustered index in where clause based on the same column where we created index non-clustered index. Okay, so this is one example for the first scenario. And second scenario where table scan is faster than non-clustered index seek with RID lookup. For this, first of all, I wanted to count the number of frequency in each first name. Okay, first Richard, Catherine, James. As you can see, James is 97, but amazingly, Richard is 5,665. Okay, from how many records? As we can see, the number of records is whole is 25. Interesting. Which one is, for example, which one is more efficient, row ID lookup or table scan in this case? So let's try to find out. Instead of James, let's see Richard. Okay, Richard. So what does SQL Server select? What do you think? For me, maybe index seek. I'm not sure. Let's try. Okay, we implemented by using Richard. Okay, so okay, SQL Server prefers to use table scan in this case, right? So you can see, implement again, table scan is being used. Why? Because SQL Server found that there are many occurrences of Richard in our data. Okay, so therefore, instead of doing row ID lookup, which might be costly, right? This row ID lookup, going to the leaf node and again then going to the heap table, right, is very costly actually when you have many occurrences. So therefore, instead of just doing this kind of operation each time, SQL Server prefers just to scan the whole table, and it found out that it is much faster. Okay, this is just an example, two scenarios where non-clustered index is not used, although created. Okay, so far we have discussed about non-clustered indexes, and now we will discuss another type of index, which is clustered index. The difference between non-clustered index and clustered index is that in a non-clustered index, as you might remember, a pointer to the actual data, row ID, RID, right, is stored at the leaf level. But in clustered index, the actual data itself is sorted and stored. For example, we created a clustered index based on the first name column, right? As you can see, the leaf node includes the actual data itself, okay, the actual data pages, which is sorted based on the column first name, based on which we created a clustered column, right? This shows that there are some important points regarding clustered index. Firstly, we cannot create more than one clustered index for one table. Furthermore, when we create clustered index, the actual data is sorted in pages in leaf node. Therefore, creating clustered index takes more time than usual non-clustered index because we should sort, right, every data in the table, so it takes time. Moreover, when sorting is happening, we should store sorting data somewhere temporarily, in temp table. Therefore, we should have enough storage for creating clustered index. This is often 1.5 times the actual data. Okay, you should have more space. Otherwise, you can that creating clustered index fails with out of storage errors. Let's try to create a clustered index and see the impact. As our previous example, we have AdventureWorks 2019 database, and we create person copy table in this database. Okay, we refresh this. I already ran this. So we refresh and go to tables. As you can see, there is a table called person copy. We check indexes and verify that there is no any index. So we run a query and see execution plan. As you can see, table scan is being used with this query, which means that the whole table is being scanned, which is very inefficient. Therefore, we create clustered index on this. Okay, not clustered, but we make it clustered index. We run, and as you can see, we have created successfully clustered index. Let's check, refresh, and you can see there is clustered index, right? So if we rerun the same command again, we can see that the query now is being run with clustered index seek. Please pay attention. It is clustered index seek. Okay. I want to mention one point also. There is also clustered index scan. Clustered index scan is equal to table scan. In the case if the whole table is scanned when we have clustered index, we called it clustered index scan, not seek. Let's see. For example, if we run only like this, right? In this case, in the clustered index is not used. But if we check here, we can see clustered index scan now, not index seek, which means the whole table is being scanned and we have clustered index. Okay. If we don't have clustered index here in this table, it would be table scan. But since we have clustered index already, we call it clustered index scan, which is equal to table scan. Please pay attention to this part. Okay, so far we discussed about heap, clustered index, non-clustered index, right? In the case of heap table structure, we have table scan. In the case of indexing, however, we have clustered index scan and clustered index, non-clustered index scan, where the whole leaf node is scanned. Okay. Among this, we found out that the most efficient way to search for data in the table is clustered index seek or non-clustered index seek, where only required part of the table is scanned. Please remember this table always. Okay, until here we came by creating indexes manually, right? However, clustered index can also be created automatically. When table is created with primary key or when table is created with unique column. As you can see, I created tables with primary and unique keys, and tables have been created with clustered indexes automatically. I just thought that this is worth to mention, right? I just mentioned this. So, okay, let's discuss about a case where we have both clustered and non-clustered index created by using following commands for the same table. In this case, as you can see, in the leaf node of the non-clustered index, business entity ID has been set instead of row IDs. For example, if we run the following query, we will end up with the following flow. Let's try this in SSMS. As usual, we create our test table, person copy. Okay, then we will populate this table and verify that index scan. I'm sorry, let's try to run this again. Verify that table scan is being used. Okay, then we will create clustered and non-clustered index as we stated before. Okay. Then we will try to run the same command. Okay. Then we can see here execution plan, index seek non-clustered and the key lookup clustered index is being used. What is the flow is first in index seek is being scanned, okay? Then it's being, not scanned, like checked. Then the flow is going to key lookup, which is using clustered index. And then the result is coming out, okay? This is a perfect example where clustered index plus non-clustered index is being used in the queries. Okay, let's discuss about also covering indexes. As discussed before, we have a long flow from non-clustered index to clustered index when we run the example query like this, right? This might be expensive operation sometimes because you should go from clustered index nodes to, from non-clustered index nodes to clustered index leaf nodes, So what is better way to make this flow shorter? This is covering index. Covering index is including required columns in the leaf node of the non-clustered index, and in this way, improving the search performance. Let's try the same in SSMS. As our previous example, we have person copy table and we created clustered and non-clustered index. If we try to run this query, we will have execution plan with index seek with key lookup, right? Clustered and non-clustered index are being used in our query. This can be expensive process, right? Costly process, I mean. So in order to resolve this problem, for example, we may try to create covering index by using first name and person type, because we are only using these two columns in our query, right? So we just create it, and let's try again. The execution plan. As you can see now, key lookup operation has disappeared. We have only non-clustered index seek, which is very efficient. Okay, and we are using person covering index, as you can see, as the index which we created now. In this way, we can improve the process with indexes, with covering index. Okay, if covering index is so efficient, why not use them always, right? The reason is the size of the index nodes of non-clustered index becomes big, right? Because you are including every column in the index nodes. Furthermore, insert and update operations become very much expensive, because every time the data is updated in the table, it should also be updated in this non-clustered index nodes, right? Leaf node, middle nodes, right? Therefore, covering index is not always implemented, and it should be implemented very cautiously. Okay, there is one way to improve the covering index, which is called include index. Okay, in the case of include index, the covering index are saved only in the leaf level, as you can see. In this way, the storage to save the index and update operations will improve. Okay, but not so 100%, but we will be able to improve slightly. Okay, this is called include index. To summarize, we talked about the importance of the index in SQL Server. Furthermore, we talked about the clustered and non-clustered indexes, as well as covering include indexes. I hope you found this video useful. Thank you for watching.